Hey everyone, welcome. I am absolutely pumped to have you here today as we unpack a truly fascinating subject and dive right into our ultimate what-if engineering mega project. Think about human achievement for a second. I mean, we have literally walked on the surface of the moon, we've constructed towering skyscrapers that pierce the clouds, and we've built massive underwater tunnels connecting entire continents. But here is the real question. Could our modern world, with all its cutting-edge technology and heavy machinery, actually replicate this 4,500-year-old marvel today, say by the year 2026? So here is our blueprint for this live mega project. We're going to look at the modern pyramid challenge, preparing the ground, cutting and moving all that stone, defying gravity with cranes, and finally, the actual price tag. Okay, let's dive into this. Section 1, the modern pyramid challenge. Before we even think about laying a single stone on our 12-acre site to reach that 147-meter peak, we have to wrap our heads around one massive number: 6 million. That is the staggering weight, in tons, of the 2.3 million stone blocks required to build the Great Pyramid. To put that into perspective, we can actually picture 6 million tons is roughly equivalent to 6 million normal sedan cars all stacked together. Crazy, right? And when you compare the Great Pyramid to, say, the Burj Khalifa, the tallest building on Earth, the modern skyscraper suddenly seems, well, almost feather-light. Weighing in at about 500,000 tons, the tallest building in the modern world is a mere 8% of the Great Pyramid's total weight. Let that sink in. Section 2, preparing the unforgiving ground. You see, it can't just drop 6 million tons of rock anywhere. Simply securing and preparing 13 acres at the Giza Plateau is going to take 3 full years of work. We're looking at costs of up to $120 million just to acquire the land and the legal permits, plus another $5 million for deep seismic scans to ensure the ground is actually stable enough. But the challenge isn't just stability, it's absolute perfection. We need extreme precision using laser leveling and GPS-guided bulldozers. Why? Because basic geometry dictates that even a tiny 1 millimeter error at the base will multiply as we build upward, creating a highly dangerous 14.7 centimeter tilt by the time we hit the 147-meter peak. So the absolutely crucial starting point is the foundation. To prevent our massive pyramid from literally just sinking into the sand and becoming a graveyard of stones, which, by the way, is a brutal mistake ancient engineers initially struggled with on the bent pyramid, we need a 4-meter-thick reinforced concrete mat. That requires 500,000 tons of concrete. That absolute necessity comes with a $400 million price tag, bringing our running bill to $550 million before a single pyramid stone is even placed. Section 3, cutting and moving mountains. This is where you really start to feel humbled by the brutal reality of this explainer's mega project, because now we have to actually source roughly $1 billion worth of solid limestone and granite. If we want to hit our crazy, ambitious 5-year timeline, we face a relentless daily cycle. We must cut 1,260 enormous blocks every single day. To pull that off, we need to buy 250 highly specialized diamond wire saws working directly in the quarries. Just the saws alone will cost $25 million and will devour an astronomical 20 megawatts of power, racking up a massive $155 million electricity bill. And once they're cut, those stones must move. That requires a massive fleet of 2,400 heavy-duty trucks to execute a $200 million transport operation. I really want to stress the compounding tension of this supply chain nightmare. Because the stone quarries in Aswan are 900 kilometers away from Giza, we must have 500 of these heavy-duty trucks driving simultaneously 24/7 for 5 straight years just to keep the project on track. No breaks. Section 4, defying gravity with cranes. This introduces what is arguably the most terrifying phase of the whole build. Taking blocks that weigh anywhere between 2 and 60 tons and lifting them hundreds of meters straight up into the air. To really grasp how extreme this gets, consider the ceiling of the king's chamber. It requires a single granite block weighing a mind-numbing 80 tons. Since no single modern crane in the world can reach that high and lift that much weight simultaneously, the laws of physics just say no, we need a workaround. We have to construct an unprecedented $300 million network of massive, specialized tower cranes. And as the pyramid grows taller, These cranes will require continuous disassembly and reassembly higher up. Add to this the 3,000 workers on site, costing another $400 million in salaries, food, and insurance, who must operate these machines with deadly millimeter precision. We're talking gaps so tight you couldn't even slide a credit card between the stones. Finally, to finish the exterior, the pyramid would be covered in 115,000 blocks of smooth white Tura limestone. This $250 million addition ensures that the pyramid shines brightly in the desert, reflecting the sun and the moonlight exactly the way it originally did thousands of years ago. Section 5. The final price tag. Okay, after 8 long, grueling years of complex planning and heavy labor, it is finally time to look at the bill for our mega project. The total budget breakdown lands at a staggering $2.95 billion. For our international viewers, that is nearly 26,000 crore INR or 82,000 crore PKR. And honestly, this massive figure excludes hidden costs like road taxes for our 2,400 trucks or the dedicated power plant we'd probably have to build just to run our massive 20-megawatt cutting operation. To really anchor this cost, let's look at how it compares to other modern marvels. At almost $3 billion, rebuilding the Great Pyramid is literally double the price of the Burj Khalifa. It's roughly equal to the construction of the massive SoFi Stadium in the United States or an enormous natural gas processing plant. Which leads us to a really fascinating conclusion. While rebuilding the pyramid is theoretically possible today, modern society would truly struggle to justify spending $3 billion on a monument that provides zero functional utility. We simply lack that sheer, obsessive religious devotion to their pharaohs that drove the ancient Egyptians to pour such staggering resources into an undertaking like this. So what you should really take away from this explainer is a sense of deep, profound awe. If recreating this structure today, using GPS bulldozers, laser leveling, massive tower cranes, and a $3 billion budget pushes our modern engineering and logistics to their absolute breaking point, how in the world did they pull it off 4,500 years ago? It's a question that completely defies logic, and it continues to challenge literally everything we know about ancient human capability.